Hello, my name is Don Pierson, and I'm from Uppsala University, the Limnology Department at Uppsala University, but I'm also one of the coordinators of the EasyMIP Lake Sector. And here today I'd like to just give you a brief introduction to the Lake Sector and what we're doing and what you can maybe do with the data that we are making available in the Lake Sector. So, what is to start with then, what is the intersectoral impact model intercomparison project, which we like to call EasyMIP for short? Basically, what EasyMIP is a project which is looking at the effects of climate change, but it's not looking at the atmospheric effects per se. It's using global climate model data that has already been produced as part of the CMIP project, which is basically right now at CMIP 6, which basically produces a series of global climate models that anyone can use to make future climate simulations of different things. But what EasyMIP does is it takes these CMIP data and makes them more easily available for use in simulating the impacts of climate change. So looking at not how the climate itself is changing so much, but how that will affect other things. And there are many different what they call sectors in the EasyMIP project. We're the lake sector. And basically what EasyMIP does that makes it so useful is it basically provides these data in a very consistent and easy to use, relatively easy to use format. And what that means is that it puts all the different, it first of all chooses a number of the climate models which it feels are most representative to use. There are many climate model simulations in CMIP 6, but they take about, I think it's around 6 models that are available. And basically then it provides those models in the same grid structure and with the same bias correction. And this therefore gives you a data set that is very consistent and can be easily used to make simulations. So this is just sort of the overview of the EasyMIP project structure. As I said, there are a number of sectors, and as you can see, there's things like agricultural, biodiversity, energy, fire, and certainly things like hydrology and forestry and so on. But then there's the lake sector, and there's two actually components of the lake sector. There's the global lake sector and a local lake sector, and I'll come to those in a little while. But as I said, the data that's available is like this climate input data, which then can go into these impact models and can be used to make assessments. In addition to the climate data, there is also other types of data. So not only climate is expected to change in the future, but things like land use, agricultural practices in cases of hydrology, perhaps building of different dams and things like that. There is also data on those things. For lake model simulations, we basically don't make use of those stuff. We mainly just focus on the climate data. So why use the EasyMIP data? It's in a consistent format. As I said, the forcing from multiple CMIP 6 GCM datasets. And again, they're on a common grid projection. That's important because if you just went and got different GCMs, they'd be on different grid projections, and it would be hard to produce a simulation of exactly the same grid cell or the same lake in a certain grid cell. They have a consistent bias correction applied to all datasets. EasyMIP has spent a lot of time developing what I consider a fairly good bias correction method. And this is based on a gridded historical data set. There's a simulation hierarchy that allows you to separate different sources of uncertainty. Um, what that means is we have a climate model, we have different scenarios, like it'd be a historical scenario and future climate scenarios under different emission scenarios. And then we also have multiple climate models, and each of those have multiple simulations. And then we can run multiple lake models with all these different climate models and scenarios. So it gives you a way to look at, to break down the uncertainty. How much is due to the lake models, how much is due to the climate models, and how much is due to the emission scenarios. And it lets you also compare. The other thing about EasyMIP is since all these, it's not just the lake sector, but there's many other sectors. It is also possible to look at the data collected by other sectors and use those in your simulations. For example, we're working now on finding ways to use the hydrology sector data to simulate the inputs of water and nutrients into lakes. So what do you get from the EasyMIP in terms of climate data? In yellow, this is basically the entire list of what we collect. Basically, and in yellow here, I put the things that we use to simulate the hydrodynamic simulations of lakes. And basically all the main meteorological data you would need to force a hydrodynamic model is provided by EasyMIP. And this is provided both in future climate, and which is usually called, in this case, would be called the EasyMIP 3B, the future climate scenarios, and also in what is 3A, which is a historical grid reanalysis data. That's this WFDE5 model. It's a global model. Again, a 0.5 degree grid, as is the EasyMIP data, the future climate scenarios. And it is both provides a historical data, that is measured data basically, but reanalyzed and gridded, and also the same data that's used to bias correct the future climate data. The different climate scenarios, basically this shows those the different climate scenarios that are available, and the different GCM models that are available. As I said, it's actually 5 models that are the main models. There's actually some secondary models now that also are available. And you get a number of scenarios for each model. This is the PI control, which is basically running a long-term simulation of several hundred years with pre-industrial carbon dioxide concentrations in the atmosphere. So you get sort of a control of what the climate would be if there was no additional carbon dioxide added. Then there's the historical simulations, which give us the model simulated changes due to historically increasing carbon dioxide concentrations in the atmosphere. And then we have 4 different future scenarios, these SP scenarios. These are basically going from very optimistic to very pessimistic increases in carbon dioxide. And finally, there's also something called a counterfactual simulation. This is something new in EasyMIP 3. This is sort of like a historical simulation, but trying to detrend the data to get away from the impacts of climate change. This allows you, this is how people now are making these simulations. When you hear in the news, for instance, that, well, this storm was much worse because of climate changes. By comparing the historical and the counterfactual simulations that you can make those kind of statements. And basically, on the left, you can see the graph that shows the different climate forcings that are available. The other thing I would say about EasyMIP is not only are these data available to force simulations, but once the data is completed, or the simulations are completed, the simulation data is then put up on the is archived on the EasyMIP data site as in a consistent format, which is .NET-CDF files. And it's also very well documented as to what types of things are saved. So, for instance, we have things about the thermocline depth, water temperature, and surface temperature, bottom temperature, so on. These are all well documented and all available from data now that we've done in EasyMIP 2 and data now that we're beginning to do in EasyMIP 3. So in the EasyMIP lake sector, we mentioned there are two parallel sort of simulation domains. There's a global simulation. This is basically where you can apply a uncalibrated lake model to over 18,000 land grid cells that have lakes. And in addition to do this, therefore, you need this, and this is entirely so far been done with hydrothermal models only. And because of the fact with hydrothermal models, we can make some assumptions about the fact that the water level is fixed or relatively consistent, and therefore you can simulate the thermal structure without having to worry greatly about the inputs and outputs of the lake. It's not totally true, but it's a reasonable assumption for many lakes. And basically, in order to do this, though, we still need some other information about the lakes in each grid cell. And that we do have also gridded data on the lake surface areas and the mean depths. And we now actually produce a estimate of a representative lake that you should use for each different grid cell of these 18,000. And then we have the local domain, and this is in case where we're using calibrated models. So we have something like 70 lakes now that we are studying, and with where we have not only the forcing data but we also have not only the bathymetric data, but we also have measured temperature profiles, and in a few cases now some measured data on nutrients and phytoplankton and chlorophyll. And in those cases we can study we can make calibrations of these lake model simulations. So rather than just running with uncalibrated models, we can actually compare the model output to the measured data and produce a calibration. And we can look at how variable those calibrations are, and hopefully that will allow us to better define the parameter sets that go into the calibrated models. And there are at least 65 people now working on the EasyMIP lake sector. So to finish off, I just thought I'd say, how can you participate in EasyMIP? There are two real ways you can do this. First of all, as I've sort of been describing, you can take this forcing data and make future climate scenario simulations. You can either do it on the global scale or the local scale. And later in the talks today, people will help you understand how better to do that. But there's basically now 73 sites available on the local scale that you can use where you could actually calibrate the model. And there's 8 sites now available for water quality simulations as well. Or the other thing you can do, which doesn't require any simulations, is you can just make use of the data that already exists. There's a huge amount of data now that's been saved from EasyMIP 2, which was based on the CMIP 5 GCMs, and EasyMIP 3, which is based on the CMIP 6 simulations. This is based on both the global and local scale. So one of the beautiful things about this is that you don't have to do the simulations. There's all this data available. What you could do is just start with analyzing that data. If you have a hypothesis about how lakes are changing with climate, you can test that using the data that is already there. in that vein, it's worth mentioning that you'll see that there's a lake sector paper idea link here you can go to and look at. If you have an idea you want to work at, you're welcome to put your idea into that paper, and it also lets you look to see if somebody else is doing the same sort of thing you were interested in. Then you could contact them and maybe be part of that project. And finally, to finish off, where are we going in EasyMap3? Well, we're looking at global lake hydrothermal simulations as we did in EasyMap2, and also local lake hydrothermal simulations as we did in EasyMap2. But in this case, they're being done in a more consistent way with the Lake Ensemble program, which I think you'll learn about more in the rest of this session. And also, we're starting to look at water quality, although it's slowly going forward because it's much more complicated. But our ambition is to also start looking at changes in water quality, not just the thermal structure. And we're trying to couple some of our model simulations with other sectors in EasyMap, particularly the global water sector. And with that, I'd just like to thank you for listening to me, and I hope the rest of the day and the Hacking Limnology session is very useful to you. Thanks.